Hello students, in this video we have 7th illustration of chapter 7 alternating current. The question is, for circuits used for transporting electric power, a low power factor implies large power loss in transmission. Explain why it is so. Power factor can often be improved by use of a capacitor of appropriate capacitance in the circuit. Explain how. Now, in what is transmission line? Transmission line is basically a long cable where you have straight wires connected, but every wire is having resistance as well as inductance. Inductance is very low for straight wire, but it is not zero. And when it comes to very large distance, that inductance is no more even negligible. So, in case of alternating circuits, we know that power is Vrms, Irms, cos delta. Now for straight line, the impedance of the circuit Z is R plus J omega L. So if I try to plot it on complex plane, what I have to do is I'll have to take omega L on vertical axis and R on horizontal axis, right? And then I can determine the Z value. This is Z, this is delta, and then we know that cos delta is adjacent R by hypotenuse mod Z. So why this is important to know? Because we are talking about power to be transmitted at constant voltage. So Vrms we are not supposed to change. We have choice between Irms and cos delta. So if cos delta, that is power factor, decreases, then Irms current passing through the line will increase. And if power factor is increased, then current can be reduced. Now, which is better choice, to allow more current to pass through the wire or less current? If you choose more current to pass through the wire, then transmission loss will increase. So this is not advisable option. And then what you are left with is this. Try to make cos delta 1. Now how to make cos delta 1? So for that I need to have delta to be 0. This delta has to be 0. Now how do I reduce delta? How do I make delta 0? So for that what we can do is, in this circuit I have fixed value of resistance, and I know what is the inductance value of the transmission line, so I can use capacitor of the same value. Capacitance will add capacitive reactance, which is opposite to omega L on complex plane, and then I can say that these two are mutually nullifying each other, and then if omega L becomes equal to 1 by omega C, then delta will be 0, and if delta is 0, cos delta will be 1. So this is why it is preferable to use capacitor, because capacitive reactance will negate inductive reactance. Power factor will be 1, that is maximum value of power factor, and if power factor is maximum, current passing through the transmission line can be minimized to minimize loss. So that was the problem. Thank you.